There's a special thing that happens sometimes. This is called a special case. It's what you've been doing. It's the same factoring you've been doing where that third term is negative. Okay, but it's like a little bit of a odd situation. And it's called difference of squares. Okay, and you're gonna see it's like sort of not new information, but then it sort of is. Okay, because it's a special case is a term we use like when something is, it's like the same that we've been doing, but it's like this interesting, there's like a twist on it. So here is an example of a difference of squares. Okay, why is it called that? Difference means subtraction, so this is a difference. And both of these numbers are squares. What does that mean? It means they're a number squared. Right? This is x squared and this is 4 squared. Okay, here's another one, right? This is, let's do this. X squared minus 81. This is a difference, right? Because it's subtraction and these are both squared. This is x squared, this is 81 squared. Okay, so these are both called difference of squares. Now, how do we factor these? Because you might be like, wait a second, you said this was like what we did, but this looks totally different. Here is the difference. And all of the other things we factored, we've had like x squared plus 5x minus something, minus 15, right? Whatever it is. We've had 3 terms. And here there are only 2 terms. Let me show you how I can make this. Let me adjust my camera. How I can make this 3 terms. Look. See that second term is not there, that term with the x. Watch what I'm going to do. Okay, so see how there's no x written? That's because we can just imagine that that's an x being multiplied by 0. So then I can use the same rule I've been using, which is I need 2 numbers that add to this and multiply to this, right? Add to this and multiply to this. So I need 2 numbers that add to 0 and multiply to negative 16. What kind of numbers would those be? Well, I know that if they're going to multiply to a negative, it's got to be 1 positive and 1 negative. And if they're going to add to 0, what kind of numbers add to 0? Well, like 7 minus 7 is 0. 5 minus 5 is 0. 10 minus 10 is 0. So this, my 2 numbers that add to 0 and multiply to negative 16 are 4 and negative 4. 4 minus 4 is 0. And 4 times negative 4 is negative 16. So here's my answer. X plus 4, x minus 4. Okay, and this is my answer. And you can see that if I multiply it back out, right? X times x times negative 4, 4 times x, 4 times negative 4. Look what would happen. These are like terms. They equal 0. And look what I end up with. Okay, let's just do it one more time so you can see it. And what I want you to do is when I do it this second time, I want you to observe and see if you can find like a little pattern or a shortcut. Okay, again, this is x squared plus 0x minus 81, right? So I'm looking for 2 numbers that add to 0, multiply to negative 81. And remember, this only works in this special case, right? This only works in this special case. So it only, this kind of shortcut that you might observe here only works when this is a square and this is a square, when it's a difference of squares. So again, 81 is a square, it's 9 squared, right? So 2 numbers that multiply to negative 81 and add to 0, that's going to be 9 and negative 9. So this becomes x plus 9, x minus 9. Okay, now you might notice some sort of trick or shortcut or structure, how to get from this to this without doing the 4 lines of work that I did. Cool. If you kind of see a shortcut, feel free to take it. But otherwise, you can always rewrite this as x squared plus 0x minus 81.